Aviation engine bearings are extremely impressive. They can rotate at a speed of up to 18,000 revolutions per minute and have a lifespan of over 50,000 hours. All along, the aviation engine is known as the crown of the industry. The complexity of its structure amazes many people. Perhaps many people don't know that there is a seemingly insignificant component whose performance actually determines the lifespan of the engine. This component is the bearing. It helps the engine firmly hold the high-speed rotating rotor, allowing it to maintain relative motion within the electronic system and ensuring stable operation even under harsh conditions. When the aviation engine is working, components like the fan, compressor, and turbine all need to rotate at high speeds. As a weak point in the engine, if the bearing malfunctions, it may cause the engine to fail completely. So, how difficult is the technology of this kind of bearing? First of all, the materials of the engine bearing must be able to withstand high temperatures. When the aviation engine is running, the internal temperature can reach as high as 1,500 degrees Celsius. At such a high temperature, most materials will either soften, melt, or lose their mechanical properties. Therefore, high-performance bearings are made of special high-temperature resistant alloy steel or ceramic materials. Secondly, the engine bearing must also be able to adapt to high rotational speeds up to 18,000 revolutions per minute. Perhaps people don't have an intuitive understanding of this. For example, the rotational speed of an ordinary electric fan we usually see is about 600 revolutions per minute, which is only 3% of the bearing's rotational speed. Such a high rotational speed means that the bearing needs to bear extremely high centrifugal force. In addition, the uneven tension in different directions of the bearing poses a huge challenge to the stability and durability of the bearing. How to design a more suitable shape, how to arrange the rolling elements to maximize the load distribution, and how to make the lubrication system more efficient to extend the lifespan of the bearing, etc. These have all become the most concerned issues for engineers. At the same time, during the manufacturing process of the bearing, high-precision machining by CNC machine tools is required to ensure that the shape and dimensional accuracy of the rolling elements reach the micron level. In this way, internal friction and wear can be minimized, and the service life of the bearing can be extended. There is also one more point. There are high-pressure areas inside the aviation engine. For the bearing to work stably in a high-pressure environment, strict sealing is essential. Otherwise, once there is a leakage of lubricating oil or the entry of external contaminants, the engine will be damaged. In the worst case, the blades will be damaged, and in the most serious case, the engine will stall. Just imagine, when you are sitting on an airplane, listening to music with headphones, and suddenly the engine breaks down, you will be in a free fall in the air. It is worth mentioning that previously, the countries capable of producing aviation engine bearings in the world were concentrated in the United States, France, Japan, and other countries. Fortunately, at present, China's aviation bearing industry already has the capabilities of design, research and development, and manufacturing. Moreover, the lifespan of engine bearings has been increased from the previous 3,000 hours to over 50,000 hours. It has to be said that this is a major breakthrough in China's high-end manufacturing industry.